In this session, we are going to learn how to find the modulus of a complex numbers. So in real numbers, the modulus or absolute value means distance of that number from the origin. So already we know this, isn't it? So let us see. Consider a number line -2 and -3. Now modulus of -3 is distance of this number from the origin. So -3 is present 3 units from the origin. So modulus of -3 is 3. Likewise modulus of 2. What about modulus of 2? 2 is present 2 units from the origin. So modulus of 2 is 2. This is in case of real numbers. So in complex numbers also, modulus means distance of that number from the origin, the very same concept. Now let us consider a complex number. Z is equal to x plus iy. We know that we can plot a complex number as a point in an organ plane. So let us consider an organ plane. This is our real axis and this is imaginary axis. So now here both real and imaginary parts are positive. So this point lies in the first quadrant. So this is our Z. Now here the horizontal distance what we have taken is x and the vertical distance we have taken is y. Now according to the modulus definition, so modulus of Z means, modulus of the complex number means distance of this number from the origin, isn't it? Distance of that number from the origin. Now this OZ, this distance denotes the modulus of this complex number Z. Now this OZ is nothing but the hypotenuse of this right triangle, isn't it? This OZ is the hypotenuse of this right triangle. So using Pythagoras theorem, we can calculate this side as root of x square plus y square. So for a complex number Z is equal to x plus iy, modulus of Z is nothing but root of x square plus y square, that is square of the real part, square of the real part plus square of the imaginary part, square of the real part plus square of the imaginary part. Let us see two more examples. So first example, let Z is equal to 3 plus 4i. Now how will you find modulus of Z? According to this definition, so root of x square plus y square, that is square of the real part plus square of the imaginary part, and finally we have to take the square root. So root of square of the real part is 3 square and square of the imaginary part is 4 square. So this value becomes 9 plus 16 root 25, which is nothing but 5. So modulus of this complex number is 5. That means this complex number is at a distance of 5 units from the origin. Let us see one more example. Z is equal to 2i, which is a purely imaginary complex number. So in this case also the very same definition. Here the real part is 0. So square of the real part is 0 and square of the imaginary part is 2 square is 4. So root 4, which is equal to 2. So modulus of this 2i is 2. Let us see two more results. Let us see two more results. First result, Z bar is equal to modulus of Z square. So already we know that Z bar is equal to, it is x plus iy into x minus iy. After multiplication, we will get x square plus y square. So already we know this result, Z bar is equal to x square plus y square. Now according to this modulus definition, instead of this root of x square plus y square is equal to modulus Z. So instead of this x square plus y square, we can write modulus of Z the whole square. So the first result what we have seen is Z bar is equal to modulus of Z square. We are going to see how to find the distance between the two complex numbers Z1 and Z2. Let us consider two complex numbers. Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. Now the distance between these two complex numbers, distance between these two complex numbers Z1 and Z2 is defined as modulus of Z1 minus Z2. Now let us see. Modulus of z1 minus z2 is equal to, what is z1? x1 plus iy1 minus z2. So minus x2 minus iy2. Now collect the real and imaginary parts separately. It is x1 minus x2 plus I into y1 minus y2. Now it's a complex number. So modulus of a complex number according to the definition. So modulus is nothing but root of square of the real part. That is x1 minus x2 the whole square plus square of the imaginary part y1 minus y2 the whole square. So just nothing but our distance formula what we have learned in coordinate geometry. Distance between 2 points is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Very same formula. So x1 minus x2 and x2 minus x1 both are same only. While squaring the value will not change. So the very same thing we are applying here. So the distance between two complex numbers is denoted by root of x1 minus x2 the whole square plus y1 minus y2 the whole square. So far we have seen how to find the modulus of a complex number, and two results we have seen. The first result is z bar is equal to modulus of z square, and the second result is to find the distance between two complex numbers. Thank you.